My phone buzzed and lit up at 2 in the morning. Someone had just connected to a network I built 3 minutes earlier. I didn't have a laptop open. There was no dedicated workstation humming under a desk. The device doing the monitoring was just that phone, running a complete penetration testing lab inside a standard app. This goes against the standard advice in cybersecurity that you need real hardware to do real security work. The industry consensus has long been that you need a proper machine, a dedicated OS, and specialized adapters. I wanted to know if that was still a technical requirement or just an outdated rule that nobody bothered to update. The experiment was to build a fully functional security testing environment using nothing but an off-the-shelf Android device. The first hurdle is the environment. You have to find a way to get a functional Linux package manager to run natively on mobile architecture that was designed for consumer apps. If it works, it moves powerful auditing capabilities for the $2,000 workstation down to a device that fits in a pocket. The environment is built on Termux. It provides a terminal that grants access to a full Linux package manager, allowing for native compilation on the phone's hardware. The setup happens quickly. In under 4 minutes, tools like Python, OpenSSH, and Nmap are running. To test it, I used the phone to scan my home network for open ports, a standard reconnaissance task. This chart shows the output. On the left, we have scan results from the phone. On the right, results from a professional workstation. The results are completely identical. The format and depth are exactly what you'd expect from a high-end machine. For these types of reconnaissance tasks, the mobile processor is keeping pace. It proves that a smartphone can successfully host and execute the software required for network auditing. But a working network scanner is not a complete lab. A lab needs the ability to test wireless behavior, not just interact with devices it's already connected to. To do that, the hardware has to support monitor mode, the ability to observe all ambient wireless traffic in the area. This diagram shows the distinction. Standard Wi-Fi is a direct, two-way conversation between a device and router. Monitor mode lets a device passively absorb all overlapping wireless signals. But most smartphone chipsets physically block this, designed to ignore unaddressed signals. Without monitor mode, you are not auditing the wireless environment. You are limited to the role of a guest on someone else's network. This is a physical constraint. No amount of software configuration can change the way these mobile chips were manufactured to handle radio waves. Online videos often show mobile hacking with flashy interfaces and rapid screen swiping, but they usually omit the technical reality of the hardware. Those demonstrations often rely on equipment kept out of the frame, specifically a way to bypass the phone's internal Wi-Fi chip. To complete the lab, you have to use an external USB Wi-Fi adapter. This flowchart shows the path. The network traffic avoids the phone's restricted internal antenna and instead routes through an external adapter that supports packet injection and monitor mode. Using that external adapter connects the phone's processing power to the raw wireless environment. It combines the portability of the mobile device with the specialized hardware required for security testing. The experiment shows that while a smartphone can now host the brain of a security lab, the physical requirements of wireless auditing still depend on specialized external hardware to get the job done.